Okay, we're going to look at some problems on confidence intervals, which were from chapter 20, unit 9, chapter 21 in our class. So I'm going to look at doing a couple different intervals. I'm going to look at doing them both with the calculator and both with the formula. So when you are taking your test, you have your choice of which one you'd like to do. So if you look at the first problem we have here, it says in a survey of a simple random sample of 100 students, 89 said they were happy going to class most of the time. So the big thing you have to figure out is this a mean or is this a proportion problem? And in this case, it's a proportion problem. Biggest way I know that is it doesn't say average, it doesn't say mean, and it says how many out of how many. So the parameter we're trying to figure out the proportion, not of the 100 student, but the proportion of all students who are happy going to class. Now, what we know is we don't know that parameter. What we know is we know a sample. We know the sample. We know p hat. We know 89 out of the 100 are happy going, which is 0.89. Now, if I'm going to do this by hand, I'm going to have to use my formula sheet, which I have. This is the formula sheet for the final exam. And as you can see, there is something that says confidence interval for a population proportion. So it literally gives you this formula to use on this problem. So all you have to do is you know that the confidence interval formula, if I'm doing it by hand, is p hat plus minus 1 z star square root of p hat 1 minus p hat over n. Now I know that p hat is 0.89, 0.89. Now my z star is something I don't know, but there is a second chart for the final exam, and it is this this confidence level chart. So since we're doing an 80% confidence interval, you can see that my z star value, my critical value, is 1.28. So my z would be 1.28. And then I'd have to figure out what the square root of 0.89, 1 minus 0.89 over 100 is. So this is my confidence interval. The easiest way to do this is I would put everything here after the plus minus in the calculator. So if I go over here and do that, 1.28 square root 0.89 times 1 minus 0.89. I'm just going to put it in just like I see it. Close my parenthesis, divided by 100. So this after the plus minus is, of course, our margin of error. So we'll say it's 0.04. So we'll say this is 0.89 plus or minus 0.04. Now, the thing we had in red, all the stuff after the plus minus, that was the margin of error. So the margin of error, the second part, is already done. So when I find my interval, so that's the margin of error, my interval, I'll just add and subtract that 0.04. So if I take 0.89 plus 0.04, I get 0.93. If I take 0.89 minus 0.04, I get 0.85. So this interval is done. It is 100% complete. Now the other way to do this, if you don't want to use the formula, that's 100% fine. If you just want to use the calculator function, that's okay. I just like to show it by hand because in case you forget what the calculator function is on the exam, you can use this. The interval function on the calculator is 1 prop z int. So a 1 proportion z interval. So if I go here over to tests, 1 prop z interval I think is down. I think it's either 0 or a. It's somewhere down here. So 1 prop zn, very easy to do. All I have to do is just put in how many I had in the sample, how many my total sample was, and what my confidence interval was. That'd be 0.80 or 80% would be fine. So this gives me 0.8499, 0.9301, which is very, very, very close to what I got with the formula. So either way is totally fine. Now, does the 80% confidence interval show there was an 80% probability that the parameter is in the interval? That's a big no, because confidence intervals do not talk about probability. They say if I construct an interval with a lot of different samples using the same method, 80% of the time it would contain the parameter. Generally, the way we write our statement, we say something like we are 80% confident that the population proportion, P, is in the interval. And you can talk about how it being students wanting to go to class and all that stuff. But in general, that's what we're going to say. We're 80% confident. There's not anything about probability in that statement. So that is a confidence interval for proportion. The biggest thing, honestly, is knowing that this is a proportion and knowing that you have to start there. So obviously the other kind of thing we could have to do is we could have to do a problem about a mean. And so the second problem is about a mean. A simple random sample of 40 students showed they had an average. So mean is an average. So there's one of my keywords. I kind of know this is good about it, but yeah, about a mean. They had an average of $15,676 in debt when graduating with a standard deviation of 4,567. So what parameter are we estimating? We're estimating the average debt for all students, all graduating students. We know the debt for these 40 students. We want to estimate the debt for all students. So this 1576 is a statistic because it's really valid only for the sample. It's valid for the 40 students, not the population. If we knew this for the population, there would be absolutely no purpose in creating a confidence interval because a confidence interval is trying to estimate the parameter, which in this case is the average debt for all students. So in this problem, it says, what is the 90% confidence interval for the mean debt of all students? So we can kind of do it the same way. I can jump down here to my confidence interval for a population mean. That would be this last formula here. X bar plus minus Z star S over square root of N. So I'll just go ahead and write that formula down. You get this sheet on the test, so you definitely will have this formula. Now the X bar is the sample mean, so in our problem it's 15,676. Z star is the same thing, but it's for a 90% in this case, so if you can see here it's 1.64. S is my standard deviation, which in this case is 4,567. And my sample size N is 40. So S is the standard deviation, N is the number in your sample, and Z is from the chart. I do it the exact same way we did above. I would find the margin of error, which is going to be all of this stuff. So I'll jump over here and just say 1.64 times 4,567 divided by the square root of 40. And that'll give me my margin of error, which is a pretty big one, but these are pretty big numbers. So this is going to yield 15676 plus or minus 1184.25. So now to find my interval, these are somewhat bigger numbers, so I'll use the calculator to actually add and subtract them. So I'll add my margin of error, 1184.25. Which is going to give me an upper bound on my interval of 16860.25. And then if I do the same thing, but I subtract, I will get 1449175. So this is my interval. We are 90% sure. Eventually here. So we're 90% sure that the average debt for all students is going to be somewhere between these two numbers, between $14,491.75, $16,860.25. Now, if you want to use the calculator for this, that's fine too. You can kind of skip a lot of this, but again, these formulas are given to you. Not z-test, that's the next section. Z-interval is what I would use for this. So let's check this out on the calculator. So we go over to test, and I go to Z-interval, which is number 7. So make sure that you see up here it says data or stats. Make sure yours is on stats. Now, sigma in our case is a standard deviation. It's the other symbol for standard deviation. So this is my 4567. Sample mean is the average, so 15676. My sample size is 40. And my confidence level is 90. So hopefully this gives us a pretty close number to what we got before, 14491. This is 14488, 16860, 16864. So a little off. The reason it's really off is we rounded this margin of error. This number actually itself, the 1.64, is actually also rounded. I think it's 1.6452 is the actual value, and the calculator does use the whole value. So it's not unusual for it to be a little off when you do the calculator. So these are just a couple problems you might see on confidence intervals on the exam. But if you have questions, obviously let me know.